Okay, everybody, welcome to Unit 2 on solving quadratic equations. We're going to begin by just taking a few look at properties of square roots. So, just as a quick reminder, a square root can be written with this radical sign with a number inside, and it is defined by the rule that the square root of a squared is equal to a. So, for example, the square root of 9 would be the square root of 3 squared, which would be 3. Now there's a couple properties I want to go over in this video. The first one is the product property. Now product in mathematics is another word for multiplication. The product of two numbers is those numbers multiplied together. So here the product property is that the square root of a times b is equal to the square root of a times the square root of b. So this means that I can break up my multiplication symbol to multiply them together. Let's verify this. The square root of 16, well, we know that's going to be 4 because 4 times 4 is 16. Let's test it out. Well, the square root of 16 is the square root of 4 times 4, which using the product property, we say it's the square root of 4 times the square root of 4, which would be 2 times 2, which is 4. So it looks like the product property works. Let's do two examples. Let's do the square root of 108. How am I going to break this down? Well, a good strategy is just to look at what numbers divide 108 so we can try and find its denominators, or try and break it down to its prime components. Well, I can see that 108 is divisible by 2, so let's write 2 times 54. And now 54 is also divisible by 2, so I could have 2 times 2 times 27, which is 54 divided by 2. Now 27 I know is divisible by 3, so this will be 2 times 2 times 3 times 9, which will become square root of 2 times 2 times 3 times 3 times 3. If I break down this 9, which I can write as the square root of 4 if I combine the 2's, let's just write 2 squared times 3 squared times 3. So what I've done here is I've broken down 108 into its prime coefficients. This is a good way for me to see how the square root is going to work out. So this is going to become the square root of, using my product property, 2 squared times the square root of 3 squared times the square root of 3. So this will be the square root of 2 squared is 2 times 3 times the square root of 3, which equals 6 times the square root of 3. And that would be my final answer, because I can't simplify the square root of 3 anymore. You could have also noticed that the square root of 108 is equal to the square root of 36 times 3, which would be the square root of 36 times the square root of 3, which would be 6 square root of 3. But if you don't notice that right off the top, this is a surefire way, whereas this one requires you to notice a little bit more about what larger numbers are divisible. Now let's take a look at the square root of 9 times x cubed. We know that we can use the product property to say this is the square root of 9 times the square root of x cubed, which will become the square root of 9 times the square root of x squared times x, which will become the square root of 9 times the square root of x squared times the square root of x. What I've done here is I've broken down this initial square root into the product of 3 square roots, and I made sure that as many square roots as I could have will be ones that have easily simplified solutions. For like 9, the square root of 9 is 3, the square root of x squared is x. So this will become 3 times x, the square root of x, and that'll be my final answer. Now on to our second property of square roots, which is called the quotient property. Quotient in mathematics is a word to say division, and so the quotient property is the square root of a divided by b is equal to the square root of a divided by the square root of b. So let's do a verification. Well, the square root of 4, we know that 16 divided by 4 is 4, so let's say the square root of 4 is equal to the square root of 16 divided by 4. Using the quotient property now, this says the square root of 16 divided by the square root of 4. The square root of 16 is 4, the square root of 4 is 2, so this would be 4 divided by 2, which would be 2. And we know the square root of 4 is 2, so it looks like that worked out. Now let's do two example problems. Let's do the square root of 15 divided by, square root of 15 divided by 64. Well, using the quotient property, this would become the square root of 15 divided by the square root of 64. Now the square root of 15 does not simplify any further because 15 equals 3 times 5. These are both primes, so there's no way to break these down further, and neither of them have a power that's higher than 1. So it looks like square root of 15 cannot be simplified. So this will become the square root of 15. Now 8 times 8 is 64, so this would become square root of 15 divided by 8. And that would be our final answer because that is as simplified as it can be. Okay, next problem. We're going to do the square root of 81 divided by x squared. Now, using our quotient property, this would be the square root of 81 divided by the square root of x squared, which will become the square root of 81 is 9, square root of x squared is x, so our final answer would be 9 divided by x.